Well, hello. Cool, that actually looked like it was helpful. Hello, and welcome back to another video. So, I've been working on, golly, what was it? I've lost my tab. This RFC for the daytime protocol. Pretty simple protocol. In fact, I've already done it. We don't need to see me cheating and using old AI. I got a few tips and tricks, as you know. It's usually wrong, but it points you in the right direction. So yeah, basically daytime protocol. If I put in the right port, we don't want to listen. That's right. I was trying out something else. It basically gives you the date. So I already have a server written up, but I'll do another one on the screen, I guess, because there's some ways for improvement there. What I thought I would do is I did a bit of stuff last night, so I've actually changed a bit of stuff, I guess. Done a few things. We'll just scroll through that. YouTube will probably hate it, the compression and whatnot. But yeah, so I basically changed some things. What I might do is just start at the start. We'll go through kind of what it's doing, and then we'll kind of talk about it. So I've kind of, as you can see, I've introduced like another couple of arenas. So I believe we talked about the connection arena last time. This time I'm getting an IOVEC buffer arena, which we can go to the definition. And it's basically a struct of IOVEC buffer, which is a struct with a buffer in it, like largest buffer that you can then use to like read into, but then you can store it in this buffer, which then has a contiguous array of struct IOVECs. And the reason for that is we now have a thing right V, and this takes in a contiguous array of struct IOVECs, and it takes a count as well. So this is something that we can kind of use to do that. We're not doing read V or anything, but that's that. So those are some new kind of variables that I've kind of chucked in. The rest is similar. So we kind of check usage stuff, and we like check things are all valid. And we talked about this Futex last time. I'm still currently using it, but potentially I could revamp things so I don't even need to use the Futex, and we do other things. So then the computer is just being nice and sleeping and just sleeping when it needs to, and not doing any busy loops or anything. So I might chuck that back up to 15. I now understand why some of my tests last night were failing. So at the moment it doesn't work. So this episode we'll get it working. So what do? We now have this last thing. So we kind of keeping track of the highest file descriptor that we get back, and it's something that we get back from Connect Socket. So we get that, and then we check whether it's bigger than a certain constant, because we're using select, and its select is put into FD sets, which you're only allowed 1024 file descriptors. So select may not be the best for like a heavy throughput, but we'll get to kind of something. But yeah, then we basically make the last be the last, and we say that once we connect to a socket, we say that we want to wait until it's readable. We basically want to check when it is next readable. What happens here? We get a connection object, then we store the file descriptor and the ID, and then we put that in a map. So I believe at the end of the last episode I was debating like, what do I need to map from what to what. And I ended up thinking I would map from a file descriptor to a connection object. So we're now putting it in the map here. And there's reasons for that. So now what I want to do is, while we have a file descriptor that is bigger than 0, cool. So at the moment, last was set to either 1 before FD set size, or there is a break somewhere in here. Yeah, there is a break if we get more than count. So if we requested less than 1024, it would break before this. And this whole thing is, so small bug. I think I don't actually continue getting stuff. So I guess once you drain it, you kind of have to do it again. So this whole thing might need to be pushed out again and in another just endless loop that you then break out at some point. Anyhow, we put it in a map. Now we get into our select call. So we first make a copy of it. I believe this works. So we have a set of file descriptors that has all the sockets that we've currently connected to, and after a call to select, it actually overwrites the what do you call it? The read set. So whatever is in here, we're passing a pointer, will get overwritten. So what I'm doing is making a copy of the original, I guess, and that way at the end of it we can kind of just loop back over it and make another copy, and as long as we keep this readable set what we kind of want, then that's good. So I'm doing a couple of prints just saying how much we selected in the map size and whatnot. Then we do this map for each. So this is a macro. It's a macro that does kind of an interesting thing. For every element over the map, it runs a code block. So this whole thing here is a code block that is like from 298 to 372. Yeah, I just need to check up on things. Where did that come in? Oh. Cool. Perfect. So now what was I doing? So basically for everything in this map, we're going to run some code. And in that block, we can assume that there are two variables that are set. One is key, and it will be set to the key type. Well, it will be set to the key of the map pair, I guess. And there will also be value. So at start off, I just set file descriptor to be key because that's what we were putting it in, and the connection to be value. Potentially, I could do a little sanity check that if connection equal null, that's probably unreachable. And because we're in like a weird thing, Vim doesn't know what to do here. But that's all right. I can use my tab button. Value and map was null. We can just say that is our unreachable condition because it seems weird, I guess. And I kind of want to do something like this. Perfect. It's kind of annoying that. Right, and what was the other thing that I should check? So I should probably check that connection FD equals FD. And if this is annoying, can we do that momentarily? And we do this. Connection FD not equal key, and we can probably put in %d not equal to %d, just so we can see the values of it as well. And so we go connection fd, and we can probably just go fd here. And perhaps I will actually call this I was down by one. We can just call that fd, and if we go here, we can go like that. So just a couple of conditions, make sure that it's correct. So now in this map, we're kind of looping through every element of the map, and then we use this as if the fd set has that file descriptor set, then we do a thing. This could probably go in another function, but I've just put it here. So first of all, after the select, we actually reset last, and then we basically go through and reset last again. But I just realized that this, I might make a comment. We need to get used to this keyboard. It's slightly different from the one in my other office, and it's very different from my one at home. It's a Moonlander. It's 2 separate keys, and the mapping is somewhat different. So what was I saying here? What if fd is no longer needed after this? That's just my little comment to myself at the moment. So we start off by basically getting a new buffer. So we declare a thing. I'm still trying to work out the best syntax for this. I'm trying to make it generic, because C doesn't really have generics. But it does have macros, which is a very textual thing. So like maybe I could even say that there, but I don't know. I would rather something that looks a bit like that, but you could, I don't know, there are some things you can do, but like you kind of need to define the structure, but perhaps you don't need to define the structure, and it just gets, who knows. Anyway, we get a buffer. If it's null, then like something bad happened. And then we basically read, because we've been told that this is readable by select. So we read it, and if we get an error, we now need to check a few things. So annoyingly, I would like to do this, like these 2 if statements in a switch case, because these 2 are kind of the same. Well, you need to check for both, but on my machine, these 2 constants are the same value, and normally, I don't even have it here. I don't have it here. Normally I would do something like, we can do if E again not equal to E would block, do something like that, and then do like a case E would block. Because if you have if you have both of the cases and they're both the same value, then the compiler will yell at you because you're trying to do a case with the same value twice. But if you do something like this, the compiler, if I get my keys right, the compiler still complains at you because you are currently inside of a macro, and you can't embed a directive within the macros, which kind of makes sense. But yeah, it kind of makes this like it's slightly inefficient, maybe. But it's all right. Basically, we do extra check, and we kind of need to do like redundancy here. The compiler might even just break this out. We could potentially even make it 3 if statements and just do a break for all of them. There's also the issue that break has a different meaning in a switch statement, so then you would have to do a default to do this thing, but yeah. So this fix me last may need updating, and I think I also want to put that fix me there. Cool. So that is if read gave an error. Basically, if we hit the end of what is available to read, we get out of this. We don't want to block. We don't want to do anything. Go on to the next file descriptor. And if we were interrupted, then do the same. Oh no, if we were interrupted by a signal, just try and read it again. I think that's what we want. Or maybe we do want this to be break. And get out, but who knows? I haven't set up interrupts yet. There's a way that you can do this, and potentially today might be the day. Who knows? Anyhow, if we finish reading, so if read is 0, then we need to we finish doing things. So what we should do is we close the file descriptor. We also need to remove it from the map, but I don't know if at the moment is the best time to do it because we are currently looping over the map. So yeah, I think like this almost needs to have like perhaps I might just do a linked list using arena, and then I can store a list of file descriptors to remove from the map, and then after this I would then look through the map. Then I would just remove it from the map, but when I remove it from the map, I'd probably also arena free the connection because the connection is no longer required. I think that's roughly how I do it, so it'll just be another arena. Arenas are quite cool. I haven't really used them before. I've seen lots about them, and I'm like, yeah, maybe it could be useful. You do kind of have to make structures and like make your code good up front, so that kind of makes sense. Cool, so at this point we've finished reading, so that means that whatever we have read so far we want to print out. What I might do is just skip that, and if we go into the point where we have read some bytes, what we do is we append to the connection buffer, which is I believe it was kind of defined there, so it's a buffer type, so it's just one of these IOVEC that I talked at the start. And we also have this IOVEC buffer, which will come into play shortly. So here we're appending the buff, which the buff was what we used to read. Now see that. Yeah, no, that's kind of alright. So here we have the buff. That is actually interesting. Yeah, I think I need to change a little thing here. So we're reading into buff/buffer, and I think this actually needs to be buff/buffer. What we can do is go into append things. Yeah, so we're seeing the base of the memory is there, and that would be why things weren't really printing out properly. So you can see here, like, no dates happen, just the date at the start, which is me running that, and that is because this needs to be buff data. And I now wonder whether I want to actually say this is maybe I'll call it a even 8 thing, just so we know that's what it is. I think this probably also needs to be EUINT 8T. Sign data doesn't really make sense over networks. It sometimes does, but most of the time it's not. But I kind of like storing it like that. It's just who I am. But this will still convert it back to just be a void star, because IOV base is just void star. So I think perhaps that will probably fix this issue here. Now we get unreachable. That's because I think I saw the bug as I was typing it, but then I didn't actually like go and change it. The bug is we do this little check here. If the file descriptor connection is the same as the file description, then it's unreachable. That is actually false, and it should be something like that. Now we should hopefully never get that. We're still not getting right stuff printed out, so that didn't actually fix what I want. I wonder whether I need to break out a little debugger. Be fun stepping through because yeah, I think map for each potentially should take a function that will accept these two types, the key and a value. Yeah, I think that's roughly what I want. And you can do whatever you want with it. So I guess I want to go back here and back here. I want to split it out into here, and perhaps it's already there. Yeah, or no, it's not. If we search for this one and go here. So map for each, I believe it's down here. So here we can call it func instead, and instead of doing code, we can do func key value. And I think that's kind of what we need to do. Now this will complain because it's like, whoa, you can't do that, buddy. It's kind of annoying. It complains in the middle of the macro. Like the errors are like not the nicest. The error here is, well, perhaps we should even wrap that like that. So I believe this whole thing, like maybe I can do that, yeah, and then that, and do that, go up, need to fix one there, I think down here, and this can be void, and what do we want to do? This was we're looping over the, I don't know. I don't know what to call the function. That's kind of annoying. But we can have something like this connection T connection, and here I can do something like that. And now what do I want to call this function? So we already have these two things here, and so I guess if we go back to, and like potentially there's stuff in here that it's like, what, you can't do that, like last, I can't really do. Perhaps I need to do the last separately, like do a separate run. Select has such a weird interface. Like, can't it work it out? I feel like it's a thing that it could work out. Anyhow, I'll go back to kind of what we do. So this see, like this, now we like don't really have this sort of information. I wonder if I allow it to have like a context. I think I like that. So we can have a maybe we can call it a context type, and the context will be like that sort of thing. And so if context equal null, we can probably just return. Maybe I don't need it. Well, I think for the way this code is, context equal null. Connection equal null, and so now map will need like a thing. So I guess if we maybe go over here and go here, so we're gonna maybe we'll call it CTX, and then here we can pass in CTX as the first parameter. Cool. So if we go back here, I kind of want to see where this was due. Map for each this one. So what do I want to call here? This is like handle select. We'll do that, and the context I think is we can call it a context T, and perhaps this can have like a context in it, and we can take a pointer to that whole thing, and our context can perhaps have, I guess, last. Well, it can be set to 0 to start with, I guess. Oh, I didn't want to do that. Take me back. This one here. Take me back here, but I want to make a new one up here, and then maybe go down here, and then oh, there was a one of the defines, I think. Yeah, this definer here. Something like that. And then like maybe take me here, sure. Type def struct, and this is a context T, and what do we have in our context? So what do we set last to? Last is just an int. So down here, oh, didn't want that. I wanted find that and ci that. Easy. I think I want to put a 1 there. So what we want to we call this handle select. Cool. Not good with naming today, but right. So read set needs to be chucked in our context, so we can look over here and maybe I'll make a context here. Context T context equals and read set, and we can just do something like that. and then this would be context dot read set. Yeah, I think that's that, and then last equals context dot last plus one, and it will kind of handle that. Cool. So that means up here we needed a FD set, read set, and what do we have now? Right. So now we need to go context that. I wonder whether we create some pointers to it. No, that's the only place we do it. This potentially we could do a few places. Yeah, I think I want to do something like this, but noting that that might not be needed. And then out here I want to just do context last equal last, something like that. Right, so we don't have a buffer arena. We can create one. Oh, I didn't want that here. I think I might go back to just the one window. So our context needs to come down a few because we need to know what some of these things are. So what was it saying? It wanted a buffer arena. Did we have one? Yeah, it was the IO-Vic buffer arena. Buffer arena. I wonder. I mean, that's. We could potentially make a pointer, but nah. I mean, we're kind of copying things around. It also means that when we make the context equal, we back there do this, and we want to do the buffer arena equal buffer arena, and I think I do want to kind of make that a pointer, and we can just unpointer it. Maybe. Otherwise, like, we're just creating a clone of it. It's already thinking that, yeah, so now it like has errors. So we do kind of get that. So this will be like a star arena, but it will happen elsewhere, and that will happen elsewhere. So we do kind of get the key things. Created a copy of rather than dereferencing lots. I don't know. It's what it is. So that was in there. So here we wanted to dereference that. So return to fur. I guess that means. What? Oh yeah, it's just there. I was like, I thought it was defined, but there you go. But you will also need. In fact, I wonder if this will complain. Yes, we don't have a rec. I guess we can just do that. and yeah, so it doesn't like doesn't complain. I think that is kind of what I want in the context. That's because we need to make it context. So we want an FD set readables, and that's just a pointer to it, but it does mean that when we do this, we should do dot readables equal to a pointer to readables. We don't care about that. Just carrying around a giant thing. What we call it? Weighted. So we'll do that, and then at the end we'll context, and what was that called? Weighted. Weighted equals weighted. So I guess that means, alright, we need to define it, context, that one. So we need to set it, so std out futex equal to std out futex, and we can just do that, giant context, and then this was a UN32T std out futex, but it was like a pointer to, is that how we do things? Yeah, it's a pointer to, and so here I want to replace std out futex with context. That I think I only use it once or twice. Cool. So we do that. Yeah, this could be like that. Fork ID. Right. So I guess I'm like, we just have to context. We just have to pass everything in the thing. Cool. Take me to the next one. Right, and then I'll take me to the context, and then fork ID. Fork ID equals fork ID. Thank you very much. Now that will complain at some point. And what is fork ID? It's a size T, isn't it? Size T fork ID. Perfect. guess we kind of want to have that. And that was a size T done. We need to do that. Buffer arena, that's just in context, I believe. But it's a pointer to it. I wonder if I do. We don't have weighted. I thought we did put weighted. Weighted. Right, so now it's going to complain about the defer, and the defer I think is just these steps here, and we should probably return rect. Cool. That's this, isn't it? Something like that. Do something like that. Cool. What do we? Now we want to do something like that. So this context here, we context. So this is kind of annoying because this I guess I need to kind of make a wrapper, or I could just do something like that, make another one. I don't know if that's a good thing. Do that, and then what was it? We needed to void out the key and void out the value because we might not use it in our code, and then we do that, and then we do our code. Do we like wrap it in that code? Just the ones. I don't know if that's needed, but I feel, and then we need to do map for each. Maybe I'll call this inline actually, inline, just to make it. I could have just done the old repeat inline. Cool. That is just all compiled. Doesn't do the right thing, doesn't print the right thing. So we're still at that point there. I needed to do things, but I think it's a bit less hectic in here. So now we set up things, so we create lots of connections, and then in here we set up a context just for this, and I believe this should be alright. So it's like on the stack, but it's on the stack for each fork, and each fork can't see the stack of the other. They have their own independent copies of the forks. And then in here we don't really need to do that. We should probably check for errors. At this point here, we probably want to do like just a pair select, and then we do a return defer exit failure. Cool. So at this point here, I should be able to do a debug. I might just do one, and I might even take for count this and just do one as well. So now it only has one fork, and we should be able to go and debug it. So if I go gdb args and we run this, and then we want to set follow mode, fork follow mode, and then we want to do the child, and then we can probably just go break, or what do we want to break on? I think I want to kind of break on this one here. So like after it's made the connections, so we can go client.c and 394. We can get the source layer. We can run, and we can get here. Cool. So, last, we have some things. We didn't get many, to be honest. We're only asking for one. Cool. So we opened up a connection, and we should select on it, and selected. So we got one thing out of it. Perfect. Now at this point here, I think I can go step, and yeah, we're now in this, and maybe here we can. We even get told in the thing there, but now we can check if that's set. That is correct. We get a last. We get a buffer. We read into the buffer. Now I kind of want to go buffer looks like a date. So we did kind of read in the date properly. Now this I kind of want to step into because it felt like we weren't doing the right thing. Now our base is looking right, 25 characters, and that is looking correct. Cool. So we need to make more because our capacity at the moment is 0 because we started off. So here we have this. Perfect. It does point to the same thing. Alright. And should just be the one thing. So do it as a string. Do it as a string. Yeah, that looks right. Cool. This perhaps is not what we want to do. I think this is the mishap that we have. So if we look at, what was it? If we look at this whole thing, but if we go connection, well, in fact, it's just 0, isn't it? If we look at that, that is what it is. After we do this arena free, if we look at it again, it's empty. Points to the same thing, but it's empty. We cleared it. That is a bug. So for each, yeah, we can then like that one there, thanks. So we get a new buffer, and that does that. So yeah, this is the thing. Because we have the data, we kind of want to keep the buffer around until after we write it. But at that point there, we don't really know about it. I just want to actually start this again. Yeah, cool. Are we not allowed to start again? We had a break point, didn't we? Yeah. Oh. Set follow fork mode child, and we can break on child client C and maybe 262, and if we run that and do layout source, so I kind of want to see what buffers. Buff is pointing there, and buffer is pointing there. But what is the not that? What is the address of that? It's the same address because of the way the structure is. So yes, it's a little tricky, but what I want to do is move this and do it basically after we print each of the things. So I guess it is like at this point here, isn't it? And that is, yeah, well, yeah. Cool, so what we want to do is we still have this, and the buff is now going to be buffer.data buffer.offset.iov base, and do it before we change offset. So yeah, that's what that will do, I believe. So if we just run that and like do 10 of them, right, cool, we're getting some dates, and we got, well, 1, 2, 3, 4 dates. Should have more. So if we try and do 1, yeah, so it's like, I kind of want to not say the critical path anymore, so let's get rid of that. Yeah, it kind of just stops, doesn't it? So we covered what happened when we like read data. We appended it to some sort of buffer, and at that point there, we kind of loop back over this one, and we do it all again. But this time we might not be able to read some data. At this point here, arena free, we want a free. What order is that? It is just, we take me back. We just it's interesting. Here we kind of want to do that order, and then don't want new. Free, because we like allocated a buffer, but then we don't actually need it. It'll still be there, so it's not like an expensive free. But that is that. Cool. So we go and loop until we read, and then we basically loop either until we can't read, and then we'll get woken up by select again, or we get to the end, and then when we get to the end, we have some other things. And I think it's hanging because it's like still thinking there's stuff to do in the map. And it wasn't printing any IDs, was it now? Yeah, it wasn't printing an ID at all, which I thought it's meant to at this point here. We needed to do an F flush, FTD out. Cool. And that is telling us things. Cool. Now, I think perhaps I want to see what the map size is again, or hard to know. So basically, when we're writing out, we get the connection buffer, and then while there is still stuff in the buffer, we write it out. This may block. Though I think I did actually make std out non-blocking. It's interesting because I'm using it in a blocking manner. Because if it gets -1, I'll just be like, meh, error. But it's secretly not. So what's like this basically does it until we go out. So like maybe I do want to just comment that because we're not currently using any non-blocking AI for that. So what we do is we basically do like a weird shuffle of buffers, because like these IOVEX are basically pointers to pointers, and then pointers to pointers, and like the pointers to pointers have a length, and so you may only write partial one of the first buffer, so to speak. So you kind of want to say, well, that's got an offset, but we'll call that a sub offset, because after you finish that one, you now want to print the write out the next one, but you also want to know where you started, because you want to free it, because that was apparently allocated with calloc, I guess. I feel like this buffer.data. Right, connection is a buffer, and it's like just this, and how do we append buffer? We do a realloc, so yeah, we do want to do a free on that data, but free, you need to know the base. It's just what it is. Cool, so that's kind of just shuffling stuff around. We check for an error, we return it, there is an error. We release the fusex if that happens as well, because we may not get to that point. And then while yeah, then we check what we have written, and basically while we have done it, it either is a partial one that we can just go, the sub offset goes up a bit, and we've finished writing, finished updating the housekeeping of the structure at that point, so we can say root equals 0, and then we'll loop out of that, break out of that. Otherwise, we need to do, well, what do we need to do? We need to get the difference between what is left and what we started off with, because there was a sub-offset thing here. So we take off whatever was left in the chunk that we were writing. At that point there, we can free that memory. And then the sub-offset is 0, and we can start on the next chunk, so we go offset plus plus, and this should empty out the buffer, and it is. Problem is, it's kind of blocking, and it's also not working, and I just like it when things aren't working. Things should just work first time. So I think here, fix me may need to remove things from map. We will. All the ones that are done need redoing. So I think here I want to bring back in these debug things. So we'll go up to history air. Fork LU, it's just one, isn't it? Selected so many map size is LU, and maybe done is LU, and weighted is LU. I don't really care about last. Maybe I do care about last. Last is that, and all of that we can go fork ID selected map dot size done weighted last, something like that. Nice little debug message. So we selected, and like now it's just finished. So the map size was 10. I think I want to do the selecting. So we select there, map size is 10, last is 12, and then here we selected 9, and I suppose we printed out 1. So I guess the last seems off. Like, why is last only? I want to get rid of that one. So last could just be 1 when. Oh, we don't want to do the +1 here, do we? We just want to do that. Cool. And did that print out 10 things? It did not. So, I guess after processed, and we can just call that yeah, like why is done 0? Done should get set there. This breaks out of that loop. That loop will go down to here, and done is not waited, it's done. Still get 0. And we do a plus equals done. Yeah, this point here, if print f is the error, and func done equal to lu, done, and we'll do it after the increment. Yeah, so in func done equals 1. I see what's happening. Now we did 7, and see if that's right. Did 8, and we printed out 8 things, and did 5. Cool. So we don't always do all of them, but that probably means that needs to be that. Because the problem is the context is getting set through all the time. So I guess this could start off with context.last. Do something like that, and then the plus equal we don't do. And we just then plus equal there, and then the last should be the last thing. Cool. Finding lots of bugs. It is a pointer. Cool. Let's not do that because it sometimes forks. So yeah, we've now like done 9 things, but we're still saying there's a bunch in there. So I think this is the point in time that we kind of make a what do you call it? What do you call it? A linked list. Because in here we might want to remove a thing. So I think at this point here, is it? Or like, I don't know. Yeah, at this point here, we kind of need to say, did we have an append? Append, and that's like an appending in a buffer, which is a particular thing. This could be anything, but we're like appending a specific thing and a specific thing, but this could this could actually take a struct o_vec just as a value. here this would just be value. And then here we go, struct IOVec, and here we go, the IOVec base is that, and the IOVec len is equal to that, and we probably need to do a brace to end that, and that should yep, so we define cool, so that works, and it still does a half-assed job, but that kind of makes way for a pin buffer to not actually be a thing. So what I kind of want to do is make this a macro, and to make it obvious as such, perhaps we can say that this is maybe I'll call it a list. No, because I'm wanting maybe we can undo all of those changes and keep in that type checking. Because what I want is a linked list with an arena type thing, not a like just dynamically aligned array. I mean, it could kind of fill the same purpose. I suppose it's the same memory use. Well, it's hard to know. One's doing like lots of small allocations, but you only have to allocate as much as you'll use in any one time. Kind of makes sense. If you use less, it's already allocated. Whereas the kind of contiguous buffer, where you're doubling in capacity every time, it's a bit more thing. So yeah, I guess what I want is just a simple. So we have a context. We don't have it currently, but I guess I'll probably have a arena, and we need to do a new. And I guess I kind of want to call it a node, maybe. And this can be a list buffer, list arena. And here we can have just a list T. So it's going to be a list. And we can call it a node. And if node equals null, then I don't know, what do we do in other cases? Not that. We do unreachables things. We did this. Arena. Cool. This one here. And this is list. Wow, this is actually just list T. Cool. So we haven't actually defined what that is, but who cares? What we can do is we probably also have a context. I guess list to delete. So this we can say node next because it's just going to have a next thing, but it's also going to have a value equals, and this is going to be just the file descriptor, I guess. And so it's going to be a very simple struct with just a value and a next, and it's going to be a linked list. So you basically have a pointer to the next thing, and we will allocate it with an arena because I don't know, I'm using arenas in this. And at that point there, I think we only want last to really get updated if it's like in one of these cases. Is that kind of what I'm thinking? I mean, even not that. So if it's an interrupt, like, but when we get the note from the kernel that there's no more data at the moment, but try again later, at that point there, we want to say, well, we still actually want to read this. And perhaps in that case, we could actually we potentially could I don't know, because we clear it in every place that we don't. What I'm thinking is we could actually start with a blank one and then kind of add in as we need, but yeah, I think doing it like this could be good. So if we do that, we stop caring about it at this point here, so we shouldn't treat that, but if we get that, we should treat it. So I think that comment was for that. So this probably is saying we don't have a list. We can make a list if you want. So we are going to have a struct list t, and in the struct we're going to have a struct list t pointed to the next, and we're also going to have what was it, int value, and this whole thing is going to be called a list t, and we're going to do arena struct of list t, and this is going to be a list arena, and then in the main, I guess we need to make a list arena. We can call that. So I noticed there is I call it different things. So not that. Maybe do something like this. Maybe do something like that. It's going to make me update things and everywhere, but I don't know, it's the way that things are, and sometimes you just want to change around things. And so in here we also want a list arena. I love how it just took me here, and so we can call that the list arena, and it is a type. So this was type. What was this? Right, so we don't have a list to delete. That wasn't actually what we want. Well, we need to keep that, but we also want a list t and a pointer to list to delete. Perfect, and we don't use it. So down here we need to make sure that we pass in our list arena, and here now we want to delete all the things from the map that we don't care about, I guess. So if we do that, we look at that. We leak memory. That's cool, but it still only prints out a couple. Did 6. Happy with those 6. Not sure why it doesn't keep going to the full 10. Like if I did 100, did 98 of them. Cool. So this arena we need to clear. That one list arena. What did I run? I think that's not a command. Help bar. Yeah, it's only used to separate commands. So yeah, there's a bunch of things. So you can't really use it in the middle. So like it's usually sure. Cool. That should stop all those leaks. So I guess now we we'll bring this out into a list T. List to delete, and we can just call that context dot list to delete. I mean, do we need to context dot list to delete not equal to null? So while there is something to do, what we want to do is map remove. Is there a remove? There is a remove. It probably wants a map, I guess, and it probably wants our context dot list to delete value, and we probably also want to make this until there, do that, and we probably want to make this the next, and then it should just kind of loop around. So things are removed from the map. Perfect. So map remove requires 4. So I believe this was just code snippet for like shit failed. Do we have a remove elsewhere? We're not actually using it in this thing, but oh no, yeah. So I kind of want yeah, map get var okay, map remove var okay, and map put val error. So I started kind of changing things to use errors, but it looks like I didn't actually get the whole way through because I wasn't using it for everything. So when we remove something, I think it can be useful to get the value out if you want it, I guess. Because, yeah, might be useful. So what happens if we do the error? We kind of just break. Alright, so we do map remove. Alright, so if an error occurs, it's like only at the end, I guess. We go if not okay, then error and then we don't take, okay, we declare, and then here we can go error. And I think I will allow us to set the variable because it can be useful when we get it out. And perhaps this could also be an error. I don't know, it's kind of like do something like that. And was that the only cases that I do something there and do something there? Come on. Yeah, I think that's potentially what I want. Cool, so map remove requires 4. So we also need like a connection to connection, I guess. And we can kind of make it null. Here we just give it the connection. I mean, because you're in a macro, you don't have to pass it as a pointer, but in like other C functions, you pass it as a pointer. So macros can be a bit misleading as to what they are doing and what they aren't. But so if this wasn't here, I think I just want to do an unreachable. Mac didn't contain FD. I don't know. We'll give it the FD, I guess. And context dot this to delete a value. It's unusual if that is the case. Connection set but not used, that's fine. We don't really care about the connection. We just, well, like, do we? We do care about the connection because the connection is made from an arena. Look at that. So when we remove it from the map, we want to free it from the map. And do that. Hey, look at that. And cool. Right, so that does that. We should remove it from the map after each time, and after we process it, we should hopefully print out a more updated map. Oh yeah, that looks interesting. So map size is 10. I don't know. It processed everything, decided it didn't need to remove anything from the map. Yes, is the error context of this to delete equals and like what is it? Context dot list to delete. I feel like I was adding to it. Can you not just work it out? It's interesting, like if you have a void start argument and you pass it in, it'll be fine with it. But if it's a printf string, oh, nah, you gotta cast that shit. Cool, so yeah, we apparently have nothing in there. Even though we don't care about that, but yeah, this, so context, sorry about that weird bump in size. We actually need to set this to be the new head. Look at that. Now we print 1, and So it's just a innumerable amount of things that we do, but we are removing stuff from the map. So we did 8 and we now have a map size of 2. So there should still be 2 in there. But last is 0. Why is last 0? Last should not be 0. I guess there is another case when we are reading our data. So when we're reading our data, so we check if it's set in the read set. But what I might do is else if fd was it just set? No, it was is set. Is set, yeah, so I want something like that, but down here, and we can just do an else of that, and here I want to do readables, and then if fd is greater than last equals fd. I think that's what it was. There were just things that weren't quite ready to read. So we selected 8. We printed 8. And here we selected 9. And we printed 9. So now we did all 10. And we did all 100. We did all 1,000. Oh, we didn't do all 1,000. We did all 100. What happens here? So we selected a whole 1,000, and last is less than the count. It has to be less than 1,024. But yeah, in here, let's have a little look-see. A buffer overflow. Fun times. That's why I do see. Hui. Just gets your heart racing, doesn't it? So up in here, we can 210 go here. Fun times. We're doing it in the middle of we're getting arena. Now, that makes it slightly trickier. And this was we're allocating. It was allocated here, and then we like overwrote it here, and it's like right after and right at the edge of a region. So I think in arena we need to maybe check that out. Arena.h and what was it? New. So what do we do in new? It's kind of annoying. Doesn't show where in the macro it is because this just gets pasted in plain text, replacing var and arena with whatever you pass in here, quite literally with buff and with star context arena. And that star is why you need to have brackets around things in macros, because if I didn't have the star/buffer arena and I put it say here, what does it mean? Like where, like do you dereference this thing, or do you try and do a dot off buffer arena, which doesn't exist because it's a pointer? It's kind of interesting. Anyhow, so in this we do a calc of size of star of red, and so this is kind of the pointer to what we're doing, and like we can get that from the arena type. I kind of want to see maybe what it is in
So what I can do is GCC minus E, is it? And client.c, and so that will just output it all. And what I can do is do this client with macro in line.c. Except we don't want to do that, we do that. And at the end of this, we can do a GCC minus fs, and it ties equals address to get that good async goodness, because that's what caught us. Otherwise, we just had it. We can do w all, w error, w pedantic, and what else am I seeing here? Oh yeah. W pedantic and W extra. That was kind of what I normally do, and we can do client with macro in line.c, and we can output it to, I guess, client. Right. Wait, what? This. What was? All right, I'll turn off all these warnings and whatnot. Perhaps just the W error. So now it is just a warning. Cool. I mean, we're using GCC. So now if I do this 1000, what does this do here? So now we need to do minus ggdb. I believe that will give me the line numbers. Yeah, so now this will give me the line numbers, but it really gives it in so if we get rid of that and then we do that, we have a new thing. Cool. And if we run that, yeah, I don't get why it's printing. What I could do is get, right, in fact I can just copy client.c to maybe temp.c, and we can copy client with macro just into there, and then we can just do this. And do like that one, set this one, and error, find error for me, that one. Now it's all just warnings, that's cool, but here we should be able to do that, and now it should print us the same things. I don't because if we look at client.c, oh, it's because it's got these lines. Yeah, that's correct. I recall this now from trying this in another project. So we need to move this back to client. So we have our original thing. Then we want to output it to that, but I want to kind of remove everything that starts with a hash on a line, everything that starts with a hash, ace, because you might, well, theoretically this doesn't have any hash like define or include. Yeah, theoretically this has already done it, so we can just remove everything with hash at the start of the line and do that, and now this should not have like a bunch of things. Cool. But now if we run this, it should hopefully give us a, yeah, so this is now telling us where in the file it was. And so what we can do with that, I want to get rid of that again and then bring this down a little. Cool, making progress. So in this file we want to go to 5673, big file there. It's kind of annoying, it's put it all on one line, but we can kind of add this up a little. Like perhaps it might be necessary to break up. So what I might do is on here we can start a macro, we can find a colon, we can just enter it, and that can be that, and that can be my macro, and I don't know, I'll do it 10 times. That look good? Cool. And then we can just run this again and run that again, and we get like L thing, and then here we can get 5, 6, 7, 8. So now it is saying this is where we do it. So it's when we get the allocated, yeah. And it's like at the end. What I think I might do is, can we get to, what are we even playing with? It's like arena, isn't it? Was it arena? It was something like that. It was in 210. Yeah, it was arena and arena new. So it was when we were doing this. So that equals that, arena.allocated equals, guess something like that. And what we're going to add to this, where arena.allocations.data and arena.allocated, and this is needing to be a void star, just cause, thanks C. And then this, we can go here, we can do that. This is now like recompiled things, but here we can kind of see what is what. So I don't know, reckons it's allocated stuff. What am I thinking with this? Perhaps I can also print out some other things in here, so we can do like arena.size is LU, and what is it? Allocations.capacity is LU, something like that. And so here we can go arena.size and allocations.capacity. See what that all has in it.
So when it craps out, the allocations capacity is only 1024. So I feel like we need to do this. If this I think I want to do this before doing that means yeah we need both those lines. So it should print it twice. So here we should have it before. It was that. It's the same data. We've allocated the same thing. The size is the same. So here, gosh, where is it? At this point here, allocations.data, that data needs to be bigger. So the capacity was only what the allocations capacity was, which I have a sneaking suspicion that is 1024, and it is. So I think I want that. Is that what I want? Or maybe I do want that. And then down here, this is going to be... Well, no, that's going to be the... Yeah, so this just needs to be allocated. Allocations. If we don't have enough, that is allocated. If we don't have enough allocated, allocate more. And the size, nothing to do with it. Because the size is just like a counter on how many things we have in there that are in use. Theoretically, the size plus the free list all counted up should be the same. So now we did 1,000, we did that. Let's get rid of some debugging things. Fprint here, to that one. So if we do that, then we do that. We should get like semi thing there. So maybe we can get rid of this. So get rid of that. We get rid of that, and fprintf and get rid of that. So now we should just get at the end there. Right, so our forks, we only have one fork, I think, from memory. Let's bump that up to 15 again. And that should be... let's compile that and then run that. And yeah, that's a bit quicker, so that's like half the speed of that for just 10,000. So now at this point here we can potentially go, I don't know, 10,000. And what was I really? 10,000 was 0.8 seconds before. It's about the same. Interesting. We still are blocking writing the standard output. And I've got ideas for that. And I think I will... potentially... I kind of want to see what... it's getting like unreachable stuff, and yeah, so we're not actually getting the full thing. Fun time. So when we do 10,000, it was fine. We do 100,000. We get some errors. All right, so 458. What is unreachable here? It's unreachable inside of Arena Clear. All right. What does Arena Clear do again? The Arena. So if we do that, I feel like we can allocate right up to capacity. Cool. It just doesn't do them all. Now, there's a reason for that. If I change this back to, say, 1 fork, I don't think I'll get 10,000. I will because I haven't compiled, but now I only got 1,021. That is because in every fork we check this and we break out before we do this. So we kind of need to do a big loop over this whole thing. And wow. I guess we can actually just check on that. So it is a pointer, but we can just dereference it. We don't need to do an atomic dereference because we're not trying to do anything else with it. We're just trying to see whether it is greater than count. Perhaps greater than equal to count. And we're actually checking while this is less than count, go and do a thing. But let's go to here and go here and then go here and then do that sort of thing. Do that. So that only goes to there. That's alright. But then we do this and then we have another one here and then we do that. So we do a bunch of forks and we, well, last ID is doing that and the last ID should get updated and at some point it will be higher than count. And then 1 dot, alright, fork size. Fork count, that's what I had. Find that and then add that there. Compile that. So now we should get all 1,000. I did a weird key there. So we should get all 1,000, 10,000, 0.8 seconds still. I feel like that's printing out to thing. So what was it for? 100k, we've actually made a difference. So that is 100k. We're not getting all 100k out though, which would be why that we had an improvement. It's not really an improvement if it doesn't go. Which I can see why. It's still only doing that. It's interesting. So I'm actually unsure if I fixed that problem. So what I might do is go back to 1 port, and if we do the 10,000, we're still only getting 121. And I wonder if that is because and perhaps if last becomes less than that and we can still get more IDs, we should churn through this. I potentially might put this thing in a little function, so I can just call it again in here maybe, because like, I don't know, like
you might do one, and then you're like, oh, I can actually connect to another thing now that I've freed up like 1,000 things. So I guess I wanted to loop over that, but the thing is, we have continue, and that's like inside of that handle select. All right. But we could. Oh, I realised that we never actually checked the return code from this little function, which I guess will just get ignored. Or perhaps I should do like another on error. Like that's probably like handle select, and there was a problem in there. But I believe that actually kind of prints out the errors when it does it. So we could probably just do a return defer exit failure. I keep on like adding code to this library, which potentially isn't needed. And so in map.h and down the bottom, yeah, and down the bottom and up these lines. So in here we also allow an error, because we do allow errors and others. So we can do that, and we can just have a contract saying that function might return its error. I think that's kind of fine. And then if that happens, we probably want to do an error. But like the error, how would we call it? It was just like that. And then we do like a break there. But we kind of, you can't, I don't know. We need to do this. So it is currently true at the start, but here we can go okay equals false, and do something like this, and then we're going to break out of here, and if not okay, then we want to break. We want to break like that, and then when we break out of there, we want to break, check for okay again, and then we'll break out of there. This one is kind of redundant because it's like a wild false, and it will just break. But I don't know, maybe posterity. Cool. So now, yeah, we're still not getting that, but yeah, now I'm checking that. Cool. This return, there'll be that. Yeah, we want that to be there. But yeah, we don't want to get out there. Maybe a little comment, end of child. And perhaps this whole thing should be like in a function somewhere. Handle child, and it'll do whatever it does. And get that here, and maybe up here, and handle child. Didn't have anything defined in it, but here we will do something like that.
and I wonder if that will kind of work. Right, so we don't have last ID. We can potentially. How many things do we not have? We have a few things. All right. I guess we need a little context. Like child context. I mean, this could just pass in all the things. So I guess what I might do is down here we can see what we need. So we can just pass in last ID. We can pass in count. We can pass in editor. We can pass in host name. We can sort out that. Cool. And now this will give me some errors. I kind of want handle child. Oh, it's probably like not reaching the end here. Alright, so what do we give it? So we have like a last ID. It wasn't a uint, it was a uint2 type, and it was a pointer. We also had count, which I cannot recall what I defined that as. It's just the size t. Size t. We have a struct in adder. Do we not? Alright, what's our host name? Is it just a const char star host name? I wonder if we should maybe put some const in so we know. Alright. Here it reckoned we don't know about count. Where do we get count from? Count is there. Cool. Right, I reckon it's just because it's failing with this. I'll just call it an int for now. Right, so what is it meant to take? It's meant to take a struct adder info, not in the adder. And it is a pointer. Do something like that. Right, so we need a in here we need an int ret equal 0. Sure. Right, so we need to pass in all these arenas. So this is going to be a connection arena T, and we'll just pass in our connection arena. We're also going to have a sure. That means this needs. Seriously? Or that means the header has turned off. That big click. That means I want to turn the header back on, which, even though I'm sitting here, I've got to do that. Perfect. Otherwise, I'll get cold and grumpy and total. Fun times. Alright, so we need a map as well. And like, look at this. This is why I kind of want to make a type def struct in here, we're just gonna go, can I go that, and then that, and then let's do that, and then find that, then replace it with that, then new line, and then there was like 5 of them, perfect, do something like that, perfect, and then here we can just go child context T and context, we'll just call this CTX, we'll just call it C actually. We let's that is alright, we can make it, I kind of want to full screen this again, then child context thing, so what do we want? We want a map, that one, don't do that, in fact, like, don't do that, and over here, can you, no, so like it, Vim just wants to do that, can I, yeah, go there, and then go here, and then child context here, so, right, here we had this, CMap as a pointer, so we'll just do that. Probably something like that. After all that. Right, so we don't have that. What do we want? We wanted a buffer arena. Did we not? Call it a thing. We did. I lost it. IOVec arena, and we're going to call this a buffer arena. We can do that, and we're going to have to like fill up all this stuff. Oh, of course. Right, so we can do that. We can do that. Right, so the can we go back here? Then list arena T, and this can be pointed to our list arena. Cool. So we don't have standard out. You did 2 T. Finally underscore there. And what was this? Is the out Futex. We don't have fork ID. Fork ID. Right, that was C, but we also need to do that. something like that. Right, so we need a defer at the end of this thing. Do we want to like do anything with it? And then we just want to turn red, I guess. But yeah, I guess we don't actually care about cleaning resources. Maybe I'll do this and 1, 0 and actually just make that a -1 explicit, and then in here we can go exit failure. Not actually checking for it, but oh well. Right, so now we need to pass in a child context. So I guess I'll need a child context here, and we can just call it ctx, I guess. And in here we need a whole lot of things. So in here we can pass in the context. What did I decide I need in it? Child context. So in here we just need all these things, I guess. So all of these things. So what do I want to do with this? I want to get all the type information away. What is happening? They're all pointers. Oh, this feels cumbersome as ever. Right, so in all of these I want to do a nom, and I want to find the colon, and I want to replace it with I want to find the colon. Actually, no, I want to just go to the start, and then I want to find the word. You know, if I want to find the colon, then I want to insert, I guess, and then equals, and then get out of insert, then paste whatever we picked up, and that'll be that. Perfect. And then all of these, yeah, I didn't really, right, so what I wanted is keep the same thing. So we find the start, and then we just add in a dot, and then we escape out of that, and then we do that. Cool. Is that what I want? Sure. Initialization of that from size t. So last ID, what do we have as a size t? Yeah, it was just that was the futex. Perfect. I think I see what is happening. It's like the window with the latest edit, which it just isn't what I want. Yeah, I thought this might be the case. So I actually wanted to replace the colons with semicolons with commas. Cool. Don't have this because that doesn't exist. And then that means that needs to be like that. We wanted to do a
selectors to all of these. Perfect. Hui, look at that. And that is looking good. Look at that. So you kind of saw it go in steps. It did like a chunk, then another chunk, then another chunk, then another chunk, then another chunk. And the reason why it has to do that is it has to kind of wait until the select pool is, we're allowed to do more, but yeah. One thing I do find kind of interesting is I kind of want where we, what did I do there? Where we do the select. Or is it not where we do the select? Yeah, so I think in here, we almost want I think what I want to do is put that inside of there. Put that like there. Is that what I want to do? And then find the spaces and then do that. And use a do while. So that way, every time we are doing a select, this looks so cursed. So while we're doing this, we're doing another loop that, hard to know how big it is, it goes all the way down there. But so we do this, then we set up our connection. So last should equal to 0 to start with, so it should connect a bunch of times, and then it'll make a little context for us, and then we'll run the select on whatever we have. We handle whatever the select is, and then we go to here. While last is greater than 0, or there's also this loop. I think I can get away with kind of doing that, and then like we do that sort of thing, and then this we don't need to care about. So that would then go to there. So now this we want to go at that point. I think that's kind of what happens. So while we can do something, so either we've stopped because last has become 0, and if that is the case, which by default is that case, then we'll do a dereference on last ID and just basically see if we can still churn more out. If that is the case, then we will basically connect as many times as we can, but we'll break out once we reach the count. Cool. And we will also break out if like if we tried one more, we would go over. I think I want this. Oh no, that's different to this. I think if this is the case, we just want to do I don't know, it's a little gross, and I think we shouldn't need it. So now if we do this, it will just run the whole thing all at once. it's a little slower, though this is not doing. So, to note, we only have one fork. We still fork, which is a little funny. But that is what it is. So, what I was going to do, so to start with, a single version with one fork. So this is when we did the forking. To start with, 10k took 2 seconds. 1.8 seconds now. Whee. And I don't know what take 20 seconds, I guess. But what happens if we bump up these fork sizes? I would have thought that it might have gotten a bit better than. Yeah, so that's 15 seconds. So there is some benefit. So it was like 20 seconds for 100k before, with just a very naive one. But now we basically taken that approach and made it non-blocking, except for the printing. We'll get to that. But I think I think if we kind of bump this back up, not that. If we bump it back up and we run 10k again, I guess, it's a lot quicker, I guess. It's still down to the 0.8 seconds, so it doesn't feel like we've actually made like heaps of stuff. But what if we do that and like do so 8.8, so that was like I also wonder whether it will be linear in growth now, because like each of these forks are like doing a kind of different amount. It is kind of still it's 7 and 8 seconds. Alright, so we haven't actually made that much of an increase, but recall that select had a limit. Had a limit. It definitely had a limit. So I guess this will take 70 seconds, well, maybe a bit less. After all this, I think all I've demonstrated is the select system core is just garbage. I don't know. I don't know if I'm not using it right. There is still the standard out issue, which perhaps I'll fix that, but maybe not in this episode. It's gotten a little long. And it's chugging. Like we're like our CPU is going a little slowly, I guess. We've got 15 tops, so we can see here. Whew, that's a lot of red, and that's just turning through. I mean, it's going through like a million. So it's kind of interesting. And there we go. Did all the work, and there was a million of them. Minute 30, I believe that's quicker. So for a million, slower. Oh well. It's kind of interesting. Select is garbage. Ugh. And I feel like, I don't know. I wonder if I'm making too many copies or like copying memory around too much, because I do note that well, no, this isn't copying it. After we read it, oh gosh, where are we, in handle, perhaps this context can go up past here, and we can just, there's another context. Is that a good place in the file? It is, perfect. Some of this will just go into that. It's kind of funny. And we're doing pointers for all the like structures. There is that using pointer, and like we'll have to like dereference them, but I think it's better than copying by value multiple times because you're basically copying the entire struct, which has a bit of things in it. Some things a bit less, like like all the arenas have like basically a list of allocated stuff, so it'll have a pointer to that list, and then it'll have kind of two. It'll have one size T for saying, yeah, and that's 64 bits. So that's like 8 bytes on this computer. Well, it's potentially more. I don't know. But yeah, there's a bit of stuff. So I think that is doing the trick. And I don't know. We do this like append buffer. I don't know if that is a stupid thing to do or not. Because potentially most of the time we just have one thing, and I guess if we did that, I don't know, each connection has a buffer, which each connection will be doing a realloc every time it kind of hits the end. So this I don't like. It's slow. And like, what are we really doing? We're kind of just. It's annoying because the right V needs to be there, and I think if I move it to so one thing I'm thinking of to make it non-blocking on the output. In fact, I wonder if this, if we just don't print out the output, who cares? Maybe if we like go here and just go to void few dex weights, and also void and futex release. We do both. Trust me. So let's make this a bit smaller. So if we do this, it was like 8 seconds. And now we're not printing out anything, so it should print out 0 for the count. So all right. We get some leaks. And we get 0. I don't know if that meant. Well, it kind of seems like if everyone's doing like around 6,000, there's 15 of them. We can have 15 times 6,000, and that's like 9,000. And it wasn't like 6,000 on the dot. It was like, some did like 7,000, some did low end 6. So I feel like this probably did it, but it's just got like a lot of leaks. And I guess that's because like we're appending to that buffer. So we almost don't want to, and it was around 8 seconds. We almost don't want to append to the buffer. So like maybe we'll do this, and we'll do a little void append buffer. So all of this is really doing is just reading, then closing once we get to the end. So now 8 seconds. Will this have memory leaks? Cool. So slightly quicker. The printing does have like a little bit of a toll. That was like 7 to 8 seconds. I'll call it that. Interesting. I don't know. Because now, I guess we do create the data. We do want to kind of remove things from the map once they're done. I do note, I do note, the map uses Calic and stuff for the buckets and whatnot. So like having an arena in here would probably help as well, because there's probably reuse. There probably is reuse. So could be that. I believe arena. We just do the Calic in there, but it's only if the free list hasn't been done. So yeah, I feel like in the map we should probably clean that up and not use the Calic and whatnot. Because yeah, they'll have some overhead. But yeah, I'm just wondering what I can do to. I kind of want to do something like this, and like, don't do that, and then find the buff and like just do, I don't know, we can actually just call it buff. We can just call it this buff, and we can just make a char buff 4096. Probably won't read anymore, but that's that. So we won't do that. Will that let me compile? Perfect. So this now is not doing as many allocations. It's similar. It will keep it back how it was. I reckon the map. The map points to, because the thing is, like, we'll remove from the map, but then when that will do it free. So we map, yeah. So if we go to free, the free buckets is in grow. No, if we do this, that is in remove. So when we find the bucket, find the thing, and we remove it, we free it. Could be better if it's just a arena free. Anyway, I think I'm rambling. Well, I know I'm rambling. I kind of want to make sure this is in a working state by kind of doing this and doing something like that. Oh wait, no, not that. Fuck man. Pardon my language. Just having, it's getting to the end of the day. Cool, so now that should still print out. Yeah, I did like 10,000. Or 100,000 I think I'm doing at the moment. Cool. I think I'll leave it there. So perhaps I will commit all this up. So we add a few things. Get add. So we have a map and also an arena. Get status. We don't really want the client with macro. And this it didn't really change. It gets commit minus m. Get select working. Not much improvement. If any. Select is quite limited. Cool, I think I might just do that. And that is that commit for the day. Perfect. I might just remove those and yeah, cool. Perfect. So next time, printing to stand it out, you kind of need an orchestrator that they will handle the printing, and you just provide them the data. So I potentially might have, once we get a buffer from the connection, what I might do is just, hey, append that to the standard out buffer after getting a lock, and then release that lock, and then that's it. Perhaps I might even do kill. I think that's roughly how I'm going to do the futex. Otherwise, possible improvements is actually getting rid of this and perhaps doing something like poll. And indeed, if you look at the select page and where it says it's an unreasonably low limit, all modern applications use poll or epoll. We'll use poll to start with. So poll might be the next one, and I believe this might even be like POSIX. Is it POSIX? Yeah, so this is from POSIX, but if we do epoll, which would be the next step, is not from POSIX. It is from Linux, and you can see that it's part of the sys thing. I do actually have quite a few sys things in here, but it is just what it is. Cool, so I think I'm rambling once more, so I think I'll call that there. Thank you very much for watching this. Sorry if the videos are a little clunky and maybe a bit longer than usual. I was hunkering down over winter, haven't really been doing this for a while, and I need to get back in it. So this is me getting back in it. Let me know what you think, and check out other videos, and I'll let me know what you enjoy, and I'll do more of them. For now, see ya.